Okay, who remembers what we were talking about at the end of last time without looking? We did something that I'd threatened to do a long time ago, but we hadn't done until now. Okay, we're heading towards doing stuff with friction, um, but uh, so the big change that we had was I started talking about problems where we're going to use a rotated coordinate system, not just the so why do we use a rotated coordinate system now? All this time we've been able to, but we never have before. So why now of all times? Why not next week? Um, so anyone remember? It does make the math simpler, yep. And the reason it makes the math simpler is, so if you have a problem where like something's moving along an inclined plane, and a lot of times you have forces that are acting parallel to the plane. Here's a list of all the forces you have. You have, well, the weight force, mg. You have a normal force. You have a force like this. And if your coordinate system is rotated, so your x-axis is parallel with the surface, then rotating the coordinate system makes this one easier. It makes this one easier. It makes this one harder, unfortunately, you know. And then there's one other thing that's simpler in the rotated coordinate system than it would have been in the standard coordinate system. It doesn't show up in the free body diagram. The acceleration. So, and acceleration is simpler. It's always just going to be a0, and then we'll solve for that variable a. Okay. The bad news is that the weight force, which was always like, that was always the easiest thing we ever had to deal with before, because it was always in the negative y direction. Now we have to think about that one. So let's imagine a problem like this, where this incline is 18 degrees. And let's say there's a force acting down of 200 newtons. It's not acting straight down, it's acting like perpendicular to the surface. And imagine there's no friction. First, draw the free body diagram of the block. And second, calculate the weight force vector. Maybe I'll do the first one and then you guys can do one after that. Okay, so a free body diagram. There's a weight. We don't know. I guess let's say it's 100 kilograms. So this would be 981 newtons. Then there's a normal force. And then there's a force of 200 newtons, like this. How are we going to orient the coordinate system? Which way does the x-axis point? Is it like up the incline or down the incline? It's up because, yeah, the y-axis always points out of the surface. And so in that coordinate system, the weight force is, anybody want to try to, with that angle? What's the angle for that weight force? Yep, that's exactly right. And the way to think about that is, imagine this weight vector at the origin of the coordinate system. The tail of the weight vector is at the origin of the coordinate system. And draw the negative x-axis and the negative y-axis. Then the angle that we want goes from the positive x-axis counterclockwise to the vector. And so you can see it falls short of making it to 270 degrees. And the amount it falls short is 18 degrees. You're always going to end up being either, so the angle of the incline with the horizontal, if it's 20 degrees, 25 degrees, that's always how much you're going to be either short of 270 or more than 270. In this case, you can see from the picture that we're short of 270, so it's going to be 270 minus 18. So theta is equal to 270 minus 18, which is 252. So the weight force vector is 981 times the cosine of 252, 981 times the sine of 252. Actually, can someone calculate those? I don't have a calculator here. Negative 0, 3 point, what? Yeah. Okay, 303.14. And then, thanks. And so then in this case, Newton's second law would be, we'd have 0n plus 0, negative 200 plus negative 303.14, negative 932.99. And that's equal to the mass, 100, times the acceleration vector, which is always going to be a0. And from that, you could calculate the acceleration. I guess in this case, it's sort of easy to calculate. It's going to be negative 3.0314 meters per second squared. And if you wanted the acceleration vector, you plug that variable back into the vector and get an acceleration vector of negative 3.03140. let's do a different one. Okay, so how about if you had a mass of 50 kilograms, it's being pushed up this incline by a 250 Newton force. Let's say that this angle is 40 degrees. Draw the free body diagram. Write Newton's second law. And calculate the acceleration vector. Okay. See if you can do that. Work together, compare answers.